the universe will be dark for 10 to the 86 times longer than any stars ever shined. This is a number that is totally incomprehensible. 10 to the 86 is 1,000,000 times larger than all of the atoms in the observable universe. So what does that mean for the nature of God? What does that mean for God's relationship with humanity? If you squeezed all of the empty space out of all of the atoms in all 8 billion people, the entire human race would fit inside a sugar cube. Two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. A belief in God is a belief in the creator of the heavens and the earth. But what if a belief in God is also a belief in the creator of other life forms, kind of like us, that have done or are doing things kind of like what we are doing now? We ready? Let's do this. Welcome to episode 6 of Things Hidden. Things Hidden is an exploration of the intersection of faith and 6 factors that surround faith: religion, physics, evolution, consciousness, philosophy, and technological innovation. The purpose of Things Hidden is to bring people into a closer relationship with God, and through that process, coming into a closer relationship with God myself. Episode 1 was the intro to Things Hidden. Episodes 2, 3, and 4 covered faith from a bunch of different perspectives. And episode 5 was about religion. If you haven't listened to those first 5 episodes, I would strongly encourage you to do that before starting this one. We are still at the very, very beginning of Things Hidden, and episode 1 is definitely the best place to start. Today we will be discussing physics. I use physics as a catch-all term for classical physics, quantum physics, theoretical physics, astrophysics, astronomy, cosmology, and the like. Basically all the stuff humanity does where we stare up into the night sky and wonder what's going on out there. We'll just use the catch-all term physics here. Physics podcasts have been a hobby of mine for many years, long before I started working explicitly on Things Hidden. I love listening to world-class experts talk about black holes, the Big Bang, cyclic cosmology, quantum entanglement, wave-particle duality, time dilation, many worlds interpretation, dark matter, multiple dimensions, wormholes, all of it. It's fascinating. But just to be clear, I really have no idea what they're talking about. The very large majority of it goes over my head. But I listen anyways. Partially because I can pick up a little bit of the discussion, and over time that knowledge compounds, even if it's a pretty slow process for me. But I also listen because I find that thinking about physics and cosmology oftentimes puts me in a state of awe that honestly feels therapeutic. And that state of awe helps me feel more connected to God. I'm also encouraged to continue this process by 3 quotes that I'll share with you now. First, Richard Feynman, one of the fathers of quantum mechanics, said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." Second, from Werner Heisenberg, also one of the fathers of quantum mechanics, "Not only is the universe stranger than we think, it is stranger than we can think." And lastly, also from Heisenberg, "The first gulp from the glass of natural sciences will turn you into an atheist. But at the bottom of the glass, God is waiting for you." That's my favorite of the 3. And I've experienced that in my own life. You start going down the physics rabbit hole, and it makes you rethink everything you thought you knew about God. But after a while, physics just made me go, yep, God exists. Before we get going any further, as a reminder, science can be wrong. We talked about this at length in episode 3. but I want to reiterate here again today, because this whole field of study has a broad spectrum of strength of consensus, and it's good to keep that in mind. When experts talk about gravity, a lot of times there is strong consensus around the point they're making. When experts talk about dark matter or the multiverse, it's much closer to guessing, and it really could be totally wrong. Sure, science could be totally wrong about gravity too, but the likelihood of that is much lower than, say, dark matter. So in this particular petal of things hidden, there are plenty of big question marks. Big chunks of the field of theoretical physics are currently untestable, so you really are just kind of guessing. But on the other hand, there are some things physics is pretty sure of, and there are some things physics is very sure of. So you have to keep all that in mind. But I have found it to be instructive to look at these various discoveries or theories or fact patterns, imagine them to be true, and then ask myself, does this make me believe more or less in the existence of a creator? Does it alter my view of the nature of that creator? If so, how? Generally speaking, this process is what I aim to do with the physics petal of things hidden. And hopefully, over time, we get to have some cool discussions with some folks that are much smarter than me. Going back to the whole awe-inspiring thing, that really is a significant part of this for me. The therapeutic benefits of feeling awe have been well-researched and are compelling. And I don't know about you, but I think the feeling of awe is getting harder and harder to come by these days. A few thousand years ago, a well-timed rainstorm was a full-blown religious experience. Fast forward to today, with insane social media overload and increasingly more realistic AI-generated graphics, our awe receptors are so fried that hardly anything actually makes us truly go, wow. But physics makes me feel awe, and it makes me think about the nature of God, and those are good things. One of the most awe-inspiring aspects of physics to me is time. Time is a real head-scratcher for a bunch of different reasons. First, and perhaps most amazingly, is how early in the universe's history we are in this moment right now. 2025 is really unimaginably early. We're 13.8 billion years into this gig. Stars will continue forming for another 100 trillion years. Then by 1 quadrillion years, all stars in the universe will have burned out. So all stars will have burned out at a point in the future that is 72,000 times further away from today than the current age of the universe is. Said differently, if the current age of the universe is 1 lap around the track, we have 72,000 more laps around the track before all the stars burn out. That feels like a long time, right? But that period of time is unimaginably short relative to what happens in the universe after all the stars die. After that, matter degenerates, and black holes start eating up other black holes, and things get increasingly weirder, and timescales stretch to unimaginable lengths. The universe will be dark for 10 to the 86 times longer than any stars ever shined. This is a number that is totally incomprehensible. 10 to the 86 is 1,000,000 times larger than all of the atoms in the observable universe. You think a quadrillion years is a long time? It's so short, you can't even measure it relative to how long the universe will continue on after all the stars burn out. So what does that mean for the nature of God? What does that mean for God's relationship with humanity? What does it mean for the future of the human species? If humanity is supposed to be the centerpiece of existence, as pitched by fundamentalist Christianity, why does the universe have the totally insane timescale that I just described? My first thought is that we will either go extinct or evolve into something that looks nothing like the way humans look now. Extinction or radical evolution, and either way, it's not going to take that long. Right now, it seems like the cyborg route is where we're going in the very near term. And that looks like it's maybe a couple hundred years out. But on, say, a 10 million year time frame, these space dust meat sacks that we're stuck in have got to go. If we make it that far, which is still not far at all on cosmic timescales, we're going to be some kind of brain-like entity floating in a vat of goo, hooked up to a vast amount of compute. Will that thing have a soul? Will that soul need to believe that Jesus Christ was the Son of God and was crucified and resurrected in order that it might be cleansed of its sin and be able to spend eternity in heaven with God? What if the brain in the vat of goo never dies? Then what? I don't know. But it makes me think that the penal substitution atonement theory probably won't be around by then. Time is also crazy because it's sort of not real. And admittedly, that's a bit of a misnomer saying that time isn't real. But it's a statement that's easier to comprehend than saying time is emergent, not fundamental. It's easier to comprehend than what Kant said, that space and time are a priori forms of intuition. They are not derived from experience, but are inherent structures of the mind that define how we perceive existence. Einstein taught us that we need to think of space and time together, space-time. And Einstein also taught us that space-time is relative. It's all relative. And this makes the idea of now, which is of such supreme importance to the nature of our existence, slightly different for every single person. There is no universal notion of now. Now is in the eye of the beholder, the eye of the observer. And this is just one of the many ways that observation becomes incredibly important in physics. As Einstein himself said, the past, present, and future are only illusions, even if stubborn ones. Part of the reason Einstein said that the past, present, and future are illusions is because time dilates. When I say time dilates, what I mean is the faster you're traveling through space, the slower time moves for you relative to someone that is stationary. It's also true that the closer you are to an increasingly massive object, the slower time moves for you relative to someone that is not close to a massive object. Time dilates because of speed, and time also dilates because of gravity. How strange is that? And so it seems that time is really not what it feels like to us, as each moment passes from an uncertain future into a tangible present, and then on into an unalterable past. And when I look around in physics, I see things like this over and over again. Things are not as they appear. Our existence is made up of layers of mirages, one on top of another. Things are not as they seem. The visible light spectrum is another great example. The visible light spectrum is the range of electromagnetic radiation that is visible to the human eye. We can see from 380 to 700 nanometers. And that's what gives us red, orange, yellow, green, blue, indigo, and violet. But the visible light spectrum is less than 1% of the entire electromagnetic spectrum that exists. Radio waves and microwaves and X-rays are all forms of electromagnetic radiation. They're the same thing as light that we can see, just faster or slower wavelengths to the point where our eyes don't detect them. What we see feels so much to us like what reality is, but that's nowhere remotely close to the totality of what's actually going on around us. Things are not as they seem. I'll give you another example. Atoms are unimaginably empty. 99.9999999% of atoms are empty space. If you squeezed all of the empty space out of all of the atoms in all 8 billion people, the entire human race would fit inside a sugar cube. Granted, saying an atom is mostly empty is like saying a spinning fan blade is mostly empty. What ends up happening is electrons move so fast and different electrons are so strongly repellent, the empty space basically ends up not acting like empty space. It's not like you can stick your hand through a door like a ghost, but what is actually going on is still not at all what it seems like is going on. Things are not as they seem. I'll give you another example. Things in the universe get unimaginably small. From a human's perspective, things get so much smaller than they get big. The largest thing we can calculate is the size of the observable universe. The observable universe is 8.8 times 10 to the 26 meters. Pretty big. The average human is 1.7 meters. The smallest thing we can calculate is a Planck length. A Planck length is basically a pixel of reality. A Planck length is 1.6 times 10 to the negative 35 meters. So a human is much, much closer to being the size of the entire observable universe than we are to being the size of the smallest particle. If you were somehow the size of a Planck length and you were looking up at another regular sized person, that person would be 200 million times larger to you than the entire observable universe is to that normal sized person. Think about that. So if there is indeed a creator to this universe, that creator deals in both the incomprehensibly large and the incomprehensibly small. Things are not as they seem. I'll give you another example. All the matter we can see, stars, planets, gas, everything, it all makes up only 4% of all of the matter in the universe. The other 96% of matter is made up of dark matter and dark energy. Scientists think 23% dark matter and 73% dark energy. But physicists really don't understand this at all. They basically stumbled upon dark matter and dark energy by backing into their existence through gravitational effects. The science could be wrong, but at this point, there are quite a few different observations that imply the existence of significant amounts of dark matter and dark energy. It's safe to say that our understanding of this is currently incomplete, but it is unlikely that it is totally wrong. Why did God make the universe act like this? Things are not as they seem. I'll give you another example. We exist in and can observe 4 dimensions, 3 spatial and 1 temporal. But there are a variety of theoretical models that predict additional extra dimensions. It is noteworthy that extra dimensions are predicted and not proven, at least not yet. Their existence is basically backed into with theoretical math, and there's disagreement about how many extra dimensions there are. Some models say only 1 extra dimension. Some models say 2 to 6 extra dimensions. String theory points to 10 total dimensions, or 11, depending on which model of string theory you're using. So the whole field of study is basically a big question mark right now. But it does seem like physicists will make decent progress on proving or disproving additional dimensions in my lifetime. If the theoretical math that points to extra dimensions ends up being confirmed by experimentation, it will just be further evidence of crazy things happening in this universe that aren't part of what we experience at face value. I could keep going with a bunch of other examples like these. The universe is filled with them. I mean, don't even get me started on quantum entanglement. It's crazy. The main point I'm trying to make here is that our perception of reality is a mirage. At this point, we really are dovetailing pretty perfectly into what Plato was talking about in his allegory of the cave. So I guess that means we're on the right track, right? We'll talk more about this in future episodes, but we did not evolve to perceive reality accurately or completely. We evolved to perceive reality in a way that allowed us to survive and procreate, a useful mirage. We don't really have any clue what's actually going on. I mean, going back to the 1% visible light example I mentioned earlier, imagine if you only saw 1% of a movie. Would you say you have any clue what that movie was about? I find this perspective to be helpful in contemplating the nature of humanity's relationship with God. Some people get really caught up in not being able to perceive God the way they perceive other things with their five senses. If they can't prove it, measure it empirically, then they assume it doesn't exist until the evidence says otherwise. The point I want to make here is that this stance is a false dichotomy, and it explicitly ignores how little we actually perceive of the world that is demonstrably around us. God exists, and God is not directly observable, just like many things exist that are not directly observable. Moving on, we couldn't have an episode about space and not mention aliens. I don't know what to think about aliens, but I start with how incredibly massive the universe is. There are on the order of 2 trillion galaxies in the observable universe. There are way more stars in the universe than there are grains of sand on Earth. Then you start running through some sort of Drake equation exercise. Drake the astrophysicist, not the rapper. The Drake equation is a framework for assessing how many alien civilizations there might be in the Milky Way that we can communicate with. It requires that you assign probabilities to a bunch of different factors that are admittedly difficult to assign probabilities to. So the exercise can produce incredibly wide goalposts depending on your assumptions. When Drake first came up with this in 1961, only the rate of star formation was even close to being known. All the other variables were completely wide open. Since then, science has made decent progress on being able to assign some probability bands to other factors. For example, we now know that approximately 20% of stars have planets that are in habitable zones, places where temperatures allow for life to potentially form, like on Earth. Up until the 1990s, the general view of physicists was that Earth was incredibly unique in the cosmos. We knew of no other planets outside of our solar system. Fast forward just a few decades, and the current estimate is that there are 1 to 40 billion habitable planets just in the Milky Way galaxy, and there are an estimated 2 trillion galaxies in the observable universe. Whoa. So progress has been made, but this Drake equation exercise still remains challenging. In particular, the last factor in the Drake equation incorporates the length of time alien civilizations exist while also being able to generate detectable signals into space. This factor immediately pushes us into Fermi Paradox discussions. The Fermi Paradox is the contradiction between the vastness of space and the age of the universe and the lack of observable evidence of aliens. How could this universe be so big and so old, and we still don't see anyone in it but ourselves? Enrico Fermi first asked this question in 1950, and podcast bros have been riffing on it ever since. So as it turns out, the hardest factor in the Drake equation to accurately ascribe a probability to is how long civilizations last at a level where they produce detectable signals into space. We don't know how to think about this because so far we have an N of 1, and it's ourselves. This is a really fascinating train of thought. How hard is it for a species to continue existing once it's become sufficiently advanced so as to produce detectable signals into space? Humanity got a little taste of that with World War II and nuclear bombs. Fast forward 80 years, and we've been holding this whole planet together with mutually assured destruction via many thousands of nukes all pointed at one another. Not exactly confidence inspiring. When we look at our own species, what we see is that we have characteristics which have developed from both natural selection and our upbringing. And when some of those characteristics are combined with technological innovation, it can put the entire species at risk. As Martin Luther King said, we have guided missiles and misguided men. You can imagine how this risk would increase in the coming decades for humanity. It seems like the magnitude of damage that can be done by a single bad actor or a small group of bad actors is increasing with technological innovation. Bioweapons in particular come to mind. So does that explain the Fermi Paradox? As it turns out, once you get advanced enough to produce detectable signals into space, pretty quickly you're also advanced enough to blow yourselves up. And that's just what happens over and over again across the universe? It's certainly possible. There was an important update to the Drake equation in 2016 from astrophysicist Adam Frank and Woodruff Sullivan. Frank and Sullivan reframed the question from how many alien civilizations exist now to are we the only technological species that has ever arisen? This conveniently sidesteps the hardest part of the Drake equation. How long does intelligent life last? With new cosmological data available and the removal of the most difficult factor from the Drake equation, Frank and Sullivan were able to make a significant advancement in our understanding of quantifying the Fermi paradox. They came up with the pessimism line. The pessimism line is the threshold probability of the likelihood of intelligent life ever existing in the universe. It goes like this. If the probability of intelligent life forming is less than 1 in 10 billion trillion, or 10 to the 22, then humans are probably the only intelligent life that has ever existed. Less than 1 in 10 to the 22. That's a really, really low likelihood. If the likelihood is higher than 1 in 10 to the 22, then other intelligent life has likely existed before. Granted, there has been some well-reasoned pushback against Frank and Sullivan's methodology, so this whole analysis remains a gray area. But if this analysis is even remotely close to accurate, it doesn't necessarily mean we aren't alone in the universe now, but it means it's really unlikely that there's never been any other intelligent life. I find this fascinating. What does all this talk about aliens mean as it relates to God? As the famous futurist Arthur C. Clarke said, two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. I'll add on to this quote. In either case, it pretty radically alters your belief of God. A belief in God is a belief in the creator of the heavens and the earth. But what if a belief in God is also a belief in the creator of other life forms, kind of like us, that have done or are doing things kind of like what we are doing now? When I think about that 1 in 10 to the 22 chance that there's never been any other intelligent life forms in the universe, I can't help but have as my base case that there has indeed been other intelligent life forms in this universe. The probability is too overwhelming. So what does that mean for those life forms' relationship with God? Those other life forms, do they or did they have souls? Were those souls faced with a decision about their eternal fate? Paradise in heaven with God, or eternal torment in the fiery pits of hell? Presumably, those aliens didn't get the same Jesus Christ we got. Did they get another Jesus Christ that came in whatever form those aliens were in? Will there be aliens in heaven? If our souls are reincarnated, can we be reincarnated into the soul of an alien life form? I won't pretend to have answers to any of these questions, but it's fascinating nonetheless. We'll dive into more detail in future episodes, but one of my main takeaways from all of this is that it points to humanity's morality being incredibly important. Because it is our morality that will end up making the difference between whether or not we destroy ourselves. We may very well be sitting at a crucial point in species development. We have created technology that has brought abundance, but has also brought the potential to destroy ourselves. And the answer to the Fermi paradox may be that many other intelligent life forms have reached this same point before, but haven't been able to make it out the other side alive. Whoa. If you've been listening to past episodes of Things Hidden, you know that I see God and morality as intimately intertwined. The way the Fermi Paradox and morality are intertwined is just further evidence of the crucial importance of morality. Perhaps in this universe, God has allowed an experiment to run over and over again across the cosmos. Life evolves until that life form is sufficiently advanced that it holds the keys to technology that provides two potential paths. The technology can either deliver complete abundance and travel to new planets, or it can deliver complete destruction. The choice belongs to the species. Honestly, this aligns with how I comprehend the nature of God and God's relationship with humanity, and I feel this in my own life. Every day, 100 times a day, I can choose to do the right thing, the moral thing, the agape love thing, or I can choose to do the wrong thing, the selfish thing, the hurtful thing, and then I can reap what I sow based on the decisions I make. That all ties together pretty well for me. A few additional points I want to make before we wrap up here today. The first is the argument for the existence of God from fine-tuning. This is a big one these days. Fine-tuning has probably brought more science-minded atheists and agnostics into belief in God than anything else over the past few years. Fine-tuning goes like this. The fundamental constants and initial conditions of this universe are incredibly precisely calibrated. So precisely calibrated that if they were off by just the tiniest amount, the universe basically wouldn't work and no life would form. These incredibly finely tuned constants imply a creator. That creator is God. The constants pointed out by proponents of fine-tuning include things like the gravitational constant, the strong and weak nuclear forces, the electromagnetic force, the cosmological constant, and the initial entropy of the universe. For example, if gravity were stronger by just 1 part in 10 to the 40, stars would burn out too quickly for life to develop. If gravity were weaker by just 1 part in 10 to the 40, stars wouldn't form at all and life wouldn't develop. There are a bunch of examples like this. It's mind-blowing. There is a rebuttal to fine-tuning called the anthropic principle. The anthropic principle states that we observe a finely tuned universe because if it weren't finely tuned, we wouldn't be around to observe it. So the only universe possible for us to observe would be one that looks finely tuned for life, so that life could form and we could observe the universe. This is an age-old debate in these sorts of circles, fine-tuning versus the anthropic principle. I won't pretend to have a lockdown answer there, but it seems to me that the anthropic principle doesn't disprove a creator. It just further highlights the need for an explanation of the fine-tuning that we see, whether that be theistic or naturalistic. It seems that the anthropic principle explains why we observe fine-tuning, but it doesn't explain why fine-tuning exists to be observed. Fine-tuning isn't a slam dunk argument for God's existence, but it is undoubtedly a great path to set off on if you are seeking. The second point I want to make is about simulation theory, which we've already discussed in episode 3. We're going to come at it from a different angle this time. I really haven't discussed quantum physics here at all today. Part of the reason why is because I don't understand it. Another reason is that it's kind of hard to just dip your toe into quantum physics for a few minutes. A third reason is that there are people way smarter than me that have all manner of explanatory videos about quantum physics on YouTube. And if you really want to dig in, you should watch those. They do a better job of it than I ever could. The point I want to make here about simulation theory and quantum physics is that quantum physics is basically exactly how you would expect a simulation to act. Seriously, reality is rendered. Particles only appear when they're measured. In computer science terms, it seems like the universe offloads rendering to the client side in order to minimize compute. And then the universe renders locally as needed on demand. It saves so much overhead to build the universe like this. There's no need to compute the interior of Jupiter unless a conscious observer actually gets there and triggers the rendering. To me, this very strongly implies a creator. I know we don't really understand quantum, least of all me, but the compute architecture of the universe seems to strongly imply intention, and intention requires an entity with intent. What is that entity? This is quite literally how video games work. You get to the edge of a map in a video game, and you don't run into a wall. The game engine just procedurally generates additional map forever, many such cases. That's basically how the universe works. To me, this implies creation, and creation requires a creator. Theoretical physicists have done work trying to think through the probability that we're in a simulation. Elon famously said he thinks there's only a 1 in billions chance we're in base reality. There is some actual theoretical math behind that statement. The most influential work on this is Nick Bostrom's trilemma in his 2003 paper, Are You Living in a Computer Simulation? The trilemma goes like this. First, civilizations rarely reach technological maturity. Second, advanced civilizations rarely run ancestor simulations. Third, we are almost certainly living in a simulation. And then the punchline of the trilemma is that at least one of these must be true. So, if advanced civilizations run many ancestor simulations, then most conscious beings, like us, would exist in simulations rather than base reality. It's kind of like those Russian nesting dolls. If you're a Russian nesting doll, what are the chances you're the most outside doll? It is noteworthy that Christianity and every other major world religion include concepts that point to humanity not existing in base reality. They don't use that exact language, but we didn't have that exact language when those scriptures were written. So they used the language they had in that day. But conceptually, it's pointing to the same thing. I want to tie back simulation theory to the earlier point where we were talking about the Fermi Paradox. If new science comes out that leads us to believe we're alone in this universe, and we've always been alone, that would drastically increase my probability that not only are we in a simulation, but that a huge portion of this universe is effectively fake. When we look up into the night sky, we're actually just looking at a really well done mural. This would actually explain a lot of what science can't figure out. It's like that movie, The Truman Show with Jim Carrey. If you haven't seen it, you should watch it. Spoiler alert. In the final scene, the main character Truman is sailing a boat trying to get away from his town. The sea looks like a never-ending horizon, but he eventually arrives at the horizon and bumps into a wall that is painted like the horizon. It's a mural that looks like distance, but it's not real. If humans are indeed alone in this universe, I think space is probably some kind of mural like that. That would certainly explain the Fermi Paradox. The third point I want to make is that it feels like humans are both incredibly special and not special at all. On cosmic timescales, the entire age of the universe up until this point is way, way less than a blink of an eye. The period of time humans have been around, even drastically less than that. So that by the time you get down to the 100 years, if you're lucky, we have in this cosmic dust meat sack, it can start feeling pretty insignificant. It can get pretty nihilistic if you're not careful. Zooming back out to the species level, if we don't blow ourselves up, we will evolve away into another species incredibly quickly. One way or another, the entire Homo sapien experiment will come and go in way less of a blink of an eye. Makes you feel kind of small, right? Makes me feel small. And yet, it is highly likely that we are far and away the most advanced species to ever exist on this planet. And there's a decent chance that not all that many species on any other planets have made it as far as we have. There's a smaller chance, but still possible, that we're the only species in the universe that have ever made it this far. Either way, humanity has hit the Powerball, the largest, most unlikely Powerball you could possibly imagine. And we hit it. And we're living it. Today, you and me, the consciousness Powerball. We nailed it. The last point I want to make is about the Kalam cosmological argument. It's named after the medieval Islamic scholarship that generated many of its key ideas. It's 1,000 years old, but its roots predate Christ. So it's kind of a big one if you're into these sorts of things. While it has gone through many versions, the current version of the Kalam cosmological argument is quite simple. It goes like this. Everything that begins to exist has a cause. The universe began to exist. Therefore, the universe has a cause. Listen to that again, slowly. Everything that begins to exist has a cause. The universe began to exist. Therefore, the universe has a cause. It's like one of those things that seem simple at first, but very quickly you start to sense how deep it is, which makes sense if folks have been chewing on it for 1,000 years. A few things come to mind when I chew on this. One, when the Big Bang was first posited, which was not even 100 years ago, that was a pretty big win for the Kalam argument. Because that second leg of the argument, the universe began to exist, by the time the Big Bang theory was initially introduced in the 1920s, the cosmology community was divided about whether the universe had a beginning. But for the centuries prior to that, science operated under the Newtonian assumption that the universe was infinite, eternal, and static. So the evidence of the Big Bang was quite a disruption to strongly held beliefs at the time. And the Big Bang so strongly paralleled the Genesis story, the scientific community actually rejected it for that exact reason. They didn't like how much the Big Bang sounded like the Bible. Seriously, go look that up. So imagine the shift that occurred in the strength of the Kalam argument when science began producing compelling evidence for a beginning of the universe. As an aside, but a compelling aside, did you know that the current cosmology community is in tight consensus around what the universe looked like 1/1,000,000th of a second after the Big Bang? But they have no idea what the universe looked like 1/1,000,000th of a second before that? How crazy is that? Kind of seems like a beginning, right? Another thing that comes to mind is cyclic cosmology. Without getting into the details, cyclic cosmology is the theory that the universe expands for a long time, then contracts for a long time, then there's a bang, and then the universe starts expanding again. It's purely theoretical at this point, but cyclic cosmology holds that there wasn't actually a beginning to the universe, just a never-ending series of expansions and collapses, hence the name. So that would call the second leg of Kalam into question. But the most compelling thing about cyclic cosmology is that it closely mirrors a foundational aspect of Hinduism. Hinduism believes in a cyclic cosmology, and they've been talking about it for like thousands of years. That's also true with extra dimensions, which we talked about earlier. A core aspect of Hinduism is the 14 lokas, or planes of existence. The 14 lokas have strong parallels to extra dimensions implied by theoretical physics. How crazy is that? But my last thought about the Kalam cosmological argument is this, and this is why I wanted to end on it. When I learn about physics and do my best to try and comprehend what I'm learning, and then when I chew on it, all of it, everything we talked about today, plus a bunch of stuff I left out, when I chew on all of that, it really makes me think there was a cause. It just feels like there is a cause. The universe is too big. It's too small. It's too complex. To me, it doesn't even feel like that much of a profession of faith to believe the universe was caused. I just look at all the evidence and arrive at the most logical conclusion. It's a longer putt to believe all this stuff somehow came from nothing than to think it was created by a creator. And I get it. There's all these evolutionary psychology reasons and cognitive science reasons why I would feel that way, even if it weren't the case. I get it. But my gut just so strongly leans this way. This existence we have and all the crazy physics stuff that goes along with it, it seems like it was caused. And if it was caused, there must be a causer. Something caused all this, and that's God. And I'm not buying that even if there may be a causer, God, that you can't know anything about that entity. That's the view of agnosticism. I don't know, and I can't know. That would not be my base case, that we can't know anything about the causer. The evidence doesn't lend itself to having that assumption. Humans have been seeking to comprehend the causer for just about our entire existence, and so much good has come out of that seeking. I think there is a causer, and I think we can seek to form a closer relationship with that entity. That's what Things Hidden is. Okay, that's it. We covered a lot here today, and we also skipped over a fair amount. Many of these topics are deep, and we barely began scratching the surface. But hopefully we formed some nice jumping off points for future discussions. If things go right, we'll get some of these physics folks on as guests, and hopefully further our understanding of all this craziness. The next episode will be about evolution. If you enjoyed this, hit like and subscribe. If you want to sign up for the blog, it's in the description. If you're looking for the online community, it's coming soon. If you know someone that would be interested in Things Hidden, send this to them. I really appreciate your time, and I wish you the best.